Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem. First, completely painted row or column. In this problem, we have to given zero index integer array ARR and an m cross n integer matrix is met, and ARR and met both contain all the integers in the range of 1 comma m into n. This is our range, and also we have to return the smallest index of I at which either a row or a column. Here the line is important, like row or a column which is completely painted in a matrix. So now let's look at their problem statement. Then we have to explain their example test cases. So first we have here a zero index integer array ARR and m cross n matrix we have to given, and the matrix both contain all the integers array with the range of, we have to given a range of m cross n, and this m cross n is a matrix, this mat, and which is each element also contains integer from 1 to m into n. Okay, and our task is to paint our task is to paint cells in matrix, and these matrix based on the order specified in ARR. And the second thing, determine we have to determine the smallest index of I in ARR. Okay, in ARR, and such that a row or a column in matrix completely painted. Like we have to find the smallest index which is painted uh, if a row is painted completely, and if it is a column is completely painted. So now let's look their approach or a idea, like, and their goal we have to also identify here. So our goal is to find the smallest index which is present in ARR, and the first is the a row in matrix. A row in matrix is fully painted, and the second one is a is column in matrix is fully painted. So we have to find this one. Okay, this one. And so now let's look at their example test cases. So in first example, we have given a ARR, these value 1, 3, 4, and 2, and the second we have to given a matrix. This is m cross n matrix, and this 1, 4 here, this 1, 4, and this 2 and 3 here. Okay, so now first we have to iterate all over the paints, and we have to update their ARR value. So we have to given ARR of 1, 3, 4, and 2, and the matrix is 1, 4, 2, and 3. And now we have to visualize these things. This is our matrix layout is this form: 1, 4, and 2 and 3. Okay, this is our layout, and so steps are, we have to follow these steps. First we have ARR of 0. ARR of 0 is equal to 1. We have given here ARR of 0 is equal to 1, and we have to follow on these steps, like where the paint is actually is painted. Basically in ARR 0 we have to paint it. So here we have this ARR of 0 is painted, so we have to track with this sign, let's suppose, and rest remains same. And same thing for another iteration, ARR of 1 is equal to 3. So here we have to paint with which position where the 3 is present. So the here is already present, already paint. Here is not paint, here is not paint, here is painted. So this is our second iteration. This is our iteration 1, this is our iteration 2, and now we have ARR of 2 is equal to 4. So here we have it is already painted, now it is painted, and this is already painted. So now one thing you notice here, we have here first row is completely painted here, like this row is completely painted. So we cannot track with another painted, like we have also discussed here, written the smallest index of I, which is either row or a column will be painted. Here he said either row, only row, or a column. It means if a row is painted completely or a column completely painted, it's not said that row and column. If row and column it's said, then we have to follow all these steps, like row is completely filled, painted, column is completely painted. But he is not said that. He is said if the row is first completed, complete the paint, so we cannot track with another options. Okay, so that's why here we have these the painted row we have to got. Now when we have to paint the row completely, in this position we have to complete the row, because the last is we have this iteration of ARR of 2, ARR of 2 is equal to 4. This ARR of 2 is 4 is completed our row painted, like when we have to paint this one, then we have to complete their row is painted. So that's why the answer of this one is index number. We have to return the smallest index of I. So here this is 0 index, this is 1, this is 2, and this is 3. So which index we have to got here? This index, this second index. So we have to return their index value, say this answer. Okay, so this 2 is our answer. And so now let's look at their example second. So in this example we have 2 8 7 4 1 8 3 5 6 9, and we have to given a matrix 3 2 5 6 2 5 1 4 and 6 and 8 7 9. So now the so now here we have their uh, layout of this matrix. The layout of this matrix is this one, like we have to follow these steps, and the layout is 3 2 5 3 2 5 1 4 and 6 8 7 and 9. And now we have to paint with these indices and these values. So here we have this is 0 1 2 3 4 5 6 7 8. So these are our index. So now first we have to paint this 2 value. Where is 2 is present? Here 2 is present, so we have to paint this one. So here we have to paint this one. Okay, so it is painted. And so next iteration we have to track this one. Okay, so next iteration we have here 8, where 8 is present, 8 is here present, so we have to paint this one. And so in third iteration where 7 is present, 7 is present here. So now we have to paint these 3 iterations. And in next iteration we have here 4, this 4 is painted. So now you look at this one, we have to achieve our goal, like if only a row painted first or a column is painted first. So here we have to achieve our column is painted first, so to we have to return the last index which we have to painted our cell, and we have to got our answer. So here index 3 is our answer. So when we have to paint 4, so then the column is painted fully. So here answer is 3. And now look at their approach for and the idea. So first we have their mapping the values, matrix values, and these values we have their first we have in map the position of all values in matrix. We have to corresponding row and column indices for the first axis during the painting, and same thing for this is for our matrix value, and the second one we have the painting the row and column to maintain two array. Okay, so we have to maintain two two arrays. First one the count of the painted cell in each row and column, and as we process each element in ARR, we have to update the row oblique column count, and we have to update their corresponding cell. Okay, and after we have check their completion, like when the row is painted, so we have to check this condition, and we cannot track again and again. And when the column is fully painted, or let's suppose row is fully painted, so then we have to return their last index which the uh, row is painted for their value. And after that we have to return the result of index I, and which a row or a column completely painted, and return the answer. So now let's look at their coding part for understand how we can solve this one. So here we have this is our code. So first we have their dimensions of matrix. So these are our dimensions, and after dimensions we have their row and column. So this is our row and this is our column. So in this we have to track their cells in a row or a column, and after we have their map of pair of this MP, and this map of each number in a matrix, its row and column we have to track here, like we have to map to track all these values uh, and their cells. And after we have their uh, these two two loops these two loops populate the map with a row and column indices for each number. Like we have to track, let's suppose we have this position, and after that we have this position, after that we have this position. So we have to find these populate this map with a row and column indices for each number. Okay, and after we have to process number in ARR, like this ARR we have to already given, like we have to iterate with their ARR, and after ARR we have get the row and column. We have to This is our row and column we have to get F first and the second, and after we have increment their painted count. If we have to paint, okay, if we have to paint, the painted count is increased, and for first value and the second value similarly. So X is our column, and Y is our row. Sorry, X is our row and column is Y is our column. And after we have there two conditions. If we have checked the column is fully painted, then we have to return index of I, and if the column is painted fully, then we have to return I, same as here. Like here the row is painted fully, and here is column is fully painted. And after that if this is our edge case, this edge case is basically for if no row and column is fully painted, then we have to return this one, answer dot size minus 1. So I hope you understand the logic and this coding implementation part. So this is a simple observation based question, and this coding is also a observation. And so now let's look at their time complexity and space complexity. So first we have mapping a matrix, map of matrix. This map of matrix we have O of m cross n matrix we have here. And same thing for processing the array. The processing of array is m cross n. So the total time complexity of this code is O of m cross n. And same thing we have here, like the space complexity is in this code is so row and column array we have to build here. So after that these are O of m plus n, and the map we have to store this map, this map of pair we have to store here, like we have to initialize here. So the storage of this one is O of m cross n, and so after this we have O of m cross n. So we have to get there, this is our time complexity and this is our space complexity. So I hope you understand the logic and their implementation part for this problem. So like we have to find simply we have to return their index value where we have to got their row is painted completely or a column is completely painted. So thank you everyone, thank you so much.